The next thing is we have what's called Euler's formula, and it's spelled Euler. He's a Swiss mathematician instead of Euler's. I know it made me think of Mrs. Euler the other day. It just made me laugh, and I'm like, no, this is Euler's formula. And he found a formula that works no matter what for every polyhedron. He had the vertices minus the edges plus the number of faces equals the number 2 every single time. And someone said you should do, you know, Valentine's enjoy flowers too, or something like that. It's a way of memorizing it. I don't care, as long as it helps you memorize. But this formula is going to be critical for identifying missing parts of polyhedrons, and so we're going to use that later. Another name that we thought everyone should know and remember is a cube. Remember, a cube is just a prism, 2 parallel bases, and all the sides are exactly the same. Like, I feel like I'm like this really cool thing on a computer screen. All right, sorry, I'm having a little too much fun. Now, here's the big things with prisms and pyramids. They're named for the shape of their bases. So your bases are going to be your parallel sides. So here, this is a triangular prism. These 2 values are your bases. So that's how I know it's a prism, because these are my quadrilaterals, and I also have the 2 triangles. This is a rectangular prism because the base is a rectangle. This one's a pentagonal or a pentagonal. Either way of pronouncing it works for me. You know it's going to be a pentagon, it's a prism. You have the 2 parallel sides. Then we have our hexagon, and this one, make sure you know it shows up all the time. And the base is just a hexagon, so hexagonal prism. Then we have our pyramids. You're going to have your triangular pyramid, you're going to have a rectangular pyramid, you're going to have a pentagon one, and you also have a hexagon one. Those are huge, that when you hear those words, you know what the base is going to be. Now let's go through with these, and you're supposed to classify the figure and name the vertices, edges, and bases on these. So the first one right here, I'd probably call that a cube. But you know, I don't know if all the sides are the same, so you could have also said a rectangular prism, because we don't know the different ones. So if that's the case, if it's a cube, you just pick 2 opposite sides, or working for the ones that are parallel. So I'd go quadrilateral ABCD and quadrilateral EFGH, and those would be the bases right here. Boom. Now you also have to identify the vertices and the edges, and the vertices are so easy because the vertices are just all the corners. Okay, so you just have to say your points and then just list them. So points A, B, C, D, E, F, G, H. I think I got myself, yep, I gotta make sure I had all of them. I was going to get more than 8, which was not going to make that a rectangular solid anymore. So that's your vertices. It's a cube. Our bases are the 2 quadrilaterals, and then we have our edges. Now edges are line segments, and if you do this one right, you should see 12 edges. You should have the edge of the bases, so that would be 4 each, and then the vertical ones that you're working with. So I'm just going to go around the top first. Segment AB, segment BC, segment CD, segment AD. Then you're going to get segment EF, segment FG, segment GH, segment EH. And you should have 4 segments so far. But now I'm going to do the vertical ones, starting on the front left. I got segment AE, I have segment BF, I have segment CG, I have segment DH. So I'm pretty cool with that, and we have the different edges and vertices to go with those. And then the next one we have what's called the Pentagonal Pyramid. So it's a Pentagonal Pyramid. The base is a pentagon, so our base, very easy to get because there's only one, is just pentagon A, B, C, D, and E. Then we have our vertices again. They're so easy to do. You should have 6 if you do it right this time. The 6 vertices at the bottom of the pyramid, and then we have the common one. So we just go, oops, points A, B, C, D, E, and F. So kind of huge that we know those. And then we also have with these our edges. Well, what are our edges? Our 5 on the bottom and the 5 going to our common point. So segment AB, segment BC, segment CD, segment DE, segment AE, and then the ones on top, segment AF, segment BF, segment CF, segment DF, and then segment EF. So we should have 10 segments with those. Now let's go to the other side and we'll finish this one up real quick. Alright, now we're going to finish using the same ones and then we're going to start over with a new section here. Now what shape would you call this figure right there? That's right, it's a cone. I have a circular base. So I have a cone. Your base is a circle. I can't really name it more than that because they didn't give me a center, so it's just a circle. We don't have any edges, so no edges. But I do have a vertex. That's going to be point N. So I do have a 1 point where we can count as a vertex. Now on the next one, what will we call that figure? I hope you realize that's called a triangular prism. It's a triangular prism. Your bases are going to be 2 triangles. So I have triangle TUV and triangle WXY. Alright, our vertices are very simple. We have our points and we name our 6 points. So points T, U, V, W, X, and Y. So we have all 6 of our points. Our edges, yeah, they take a little bit more here, but it won't be too bad. We have segment WX, segment WY. We have segment XY. We're going to have segment TU, segment TV, and segment I can't even think here, segment UV. So when we have those, so we have at least 6 of those that we're working with. Alright, we're going to take a quick break and then we're going to come back and finish up some of the rest of this page.